So hi, and thank you for attending this talk about infrastructure drift and how you will probably never catch them all. So, bonjour, hi, I'm Stefan. I'm S. Jordan on Twitter, on GitHub, and GitLab, and pretty much anywhere else on the internet. I've been in operations for the past 20 years. I co-founded some tech companies in Canada, in Europe, as well as one sound studio, pretty much though. I also co-founded Drift Control. This is a tool for us, DevOps, that manage Drift, and I will have the honor to present it to you at the very end of this talk. So it's Drift Control on GitHub. I also co-wrote Infrastructure as Code cookbook for Pact like 4 years ago, and I co-wrote it with Pierre. Salut Pierre, hello Montreal. So basically, what's about the agenda? What are we going to talk about today? Pretty straightforward. 3 major parts. First, it's going to be about infrastructure as code, all the good intention and the ideal world each of us entered in when we started, and how it's actually going, how it started, how it's going, and maybe like it was maybe different from what we expected. So we'll see. Then we'll drift together using Terraform and AWS live coding, you and me, like demos and terrible stories we can tell, and how things also went really wrong. So at the end, finally, I will present our own open source answer to our own problems, Drift Control, Drift CTL, and at the end of the talk, hopefully, we'll have a couple of minutes together for a quick Q&A session. So, what is it about this infrastructure drift? This is a quick definition. Infrastructure drift is what happens when the reality and the expectations don't match. Also known as "oh my god" in production, when things go really wrong, and that was pretty unexpected. So, what about this ideal world, this vision for a bright future that infrastructure as code was to offer us, like Plato's Republic was for the society a while ago? So we would have a single source of truth that would be the state in the case of Terraform toward the code. We would have versioning with Git. The code would be so great that it would be self-documenting. In this ideal world, we would have testing everywhere on the pipelines, before and after, TDD and BDD, etc., like the rest of engineering. Collaboration would be a bliss between teams, as you should. Infrastructure would be immutable. We could scale up and down and throw the rest away. GitOps would be everywhere. CI/CD for infrastructure, no more locally running things. And basically all the credentials would be under control, and multi-cloud will solve all our problems because, API everywhere, and we will have the skills to handle all those APIs and time to do this so greatly and in a matter of time. So that's great. That's basically how it started, and you probably relate. But how is it actually going? Marcus Aurelius, the Roman emperor, a few centuries after Plato, he wrote to himself in a notebook, do not expect Plato's ideal republic. And as it happens, we're not Roman emperors, okay, but our ideal republic is not to be expected either. So how it started is not exactly how we saw it going, So in the team, many of us were quite experienced, but we wanted more feedback about that experience, the way we were feeling. And so we just asked to hundreds of DevOps, CTOs, etc., around the world, what they were in their infrastructure as code journey. And basically, what they told us was that changes were still happening outside of infrastructure as code. Many reasons for that, but mainly manual changes and scripts that were changing tags or whatever, and lambdas updating things after deployment, etc. So a lot of changes were still happening outside of infrastructure as code. So be it Terraform, be it Pulumi, or whatever infra as code tool you use, doesn't matter. But also a bunch of other things as well, like basically the scope of change wasn't very often fully committed because very often of broken processes. People were like changing things manually on the web console for AWS and then backporting the changes in Terraform until Terraform stopped screaming, which means as well that people were still running Terraform locally with the right access keys on their own laptop. Terrible processes. And basically everybody knows that once you click everywhere on AWS console, things a lot of other things are deployed by AWS on the background, and so your Terraform code doesn't reflect exactly what's actually deployed online. So many people were aware of the good practices about the testing requirements, frameworks like TerraTest, etc. But most of them never had the time to learn and write and those tests, and sometimes it was even too costly to run for them. So basically, communication was still an issue for many teams. Async, even in those COVID-19 times, is still a major issue to communicate between teams. Immutable infrastructure is still a great struggle to achieve. A lot of the new projects are running more or less around this, but you still have legacy, those thousands of VMs that you are running every day. So that's what I'm talking about. And basically, a lot of people were still gaining console access. And guess what? People with console access tend to change things on their access. And unless you lock them down completely, which is sometimes not possible because it's the boss, because it's the customer, because it's this special coworker who needs to do that special thing manually on the web console, problem will happen. Many people were still having issues with skills on their team for some new IS provider or something. Like the full team was very skilled on GCP, and for some reason this new project needs to run on Azure, and all the specifics for this provider is not immediately known to most of the team. So you end up with maybe bad practices in your infrastructure as code deployments. So, and basically, even if you have not many problems with that, everything that has an API is still not under infra as code. We've heard terrible stories about GitHub accesses not deployed using Terraform or DNS records, etc. Anything that can be used with Terraform wasn't yet by far deployed. So basically, all those behaviors have something in common. They generate drift, they lead to drift. So while it's pretty cool for cars, as we can see in this image, if you find it cool, basically the discrepancy between intention and reality can lead to major issues, disasters from security, misconfiguration, etc. It can be a real major pain. So most of the people that we met put something in place, like Terraform plan and apply in cron tab or in CI/CD somewhere before and after some commits, etc. But well, we love Terraform, definitely. We love HashiCorp products. Terraform is an excellent provisioner, but it's not fair to attack the tool on something it's not meant to do. So anything that is outside its scope, it's just normal that Terraform doesn't get. So if there is a lot of changes that cannot be seen by Terraform, well, let's build maybe a tool to do it, but do not say that well, Terraform doesn't see it. So basically, for everything that is outside the scope of Terraform, that's about security and compliance tools, and there are a very different type of software. So unfortunately, many of us expected Terraform plans in cron tabs and cron jobs in CI/CD to report changes because some of the resources were managed by it. But unfortunately, we're gonna see it, but right now, it's not always the case. So let's get started with the stories. So the stories, there will be 3 of them. So around IAM, S3, and security groups, and basically they are based on real stories that we simplified for this talk. So it's still easily understandable, looking at the code quickly on during the conference. And basically the full story goes like this. There is an intern. He has a read-only access, and he ended up with access keys controlled by no one, and those keys were linked to an administrative policy, and nobody noticed. So how comes it ended up like this? So let me share my terminal. So basically, this is a small. It's a very tiny Terraform, so configuration file. We have a user, we have a key, we have a policy attachment. It's for read-only, so it's very easy. As I said, it's simplified for this talk. And so now, basically, let's apply this configuration. It's gonna take a few seconds. All right, and basically, yeah, it's creating the bucket for the next demo, the VPC, the security group. Okay, got it's done. So now let's move to the developers console, and we say, okay, we have this intern MostQ3 IAM user, and we can confirm that there is the key that was created by our own code. So the story goes like this. This intern went to the DevOps guys and said, okay, I cannot use my key for some reason. And the guys were in a rush, and they said, okay, they logged in to the management console, and they activated it, the key for the intern, and created a new one, and saying to themselves, all right, I'm pretty sure we're gonna remember it, and we're gonna add it to Terraform just in a few moments. And on top of that, Terraform will notify us if we forget. So if we go back to the terminal, in this case, what do you think would happen? Terraform apply on this IAM user. Basically, nothing. So in our case, while the very simple use case may have led our users to think that this specific key and user would notice any report any change. It was not the case. So the story continues with this user. The user comes back 1 hour later and say, okay, I still can't do things. Please do something. And the DevOps guys did not have the time to look into it. So what they did is, okay, let's give you administrative access so you can change whatever you want, and we'll revert those permissions quickly after. So what do you think in this case Terraform would find? And with our Terraform apply, as we have a policy attached to the IAM user, everything is in Terraform, is managed by Terraform, and this team was sure that this was to be reported in Terraform plan, Terraform apply, and it wasn't the case, because basically, well, it's out of the control of Terraform. It's just an attached resource. It doesn't work like that. So they forgot about it. They went on with the day, they went on with their lives, and weeks after that, they realized, oh, that intern, where is he? And there was a key, an administrative key out there in the wild, uncontrolled by anyone, not even mentioned as deactivated on the code. Plus, it was it had an administrative access. So for auditing purposes, it was a nightmare. So let's go back to the slides. The next story is quite similar in the sense that it starts with with someone or a process. You can have lambdas, scripts, etc., that have administrative access on some resources on the scope, very delimited scope. And in this case, someone with an administrative access open everything to anyone on IPv4 and IPv6, and no one noticed anything. So how did it go? How did it went? So let me go to VPC. We are in US East 1. Let me go to the security groups. All right, so we have our super secure security group that we created using Terraform. Let me show you quickly my terminal. So we have the security group, it's empty, and we have a rule that is attached to it. So here it is. We allow SSH for this local network. So here it is, and sorry, let me show you AWS. So I have our super secure security group, and we have our SSH rule for allowing SSH to this local network. So now, what happened? Somehow, so for the sake of simplicity, we do it manually here, but somehow something could change this specific super secure security group and could allow anything anywhere on any kind of networks on IPv4, etc., and name it very carefully, like temp. So, those temporary rules that we'll remember soon to change. So what happened there? Now, something with the correct access rights allowed anything to anywhere on this network behind this security group. So let me show my terminal. And now, basically, this team, they expected any kind of rules that was added or modified to be reported as well on Terraform. And while it is true for a rule, it is not true for a new rule. And basically, this poor team went weeks or months with such a rule live on their system. Terrible. So what's next? Let me change to the slides. All right. And our last story is S3, terrible. So this team quickly, they were building a lot of stuff on S3. They were putting a lot of their binaries there and removing them. So obviously they removed the versioning. For some reason, long story short, someone activated versioning on all the buckets for the company, including this one, but they were pretty sure that it wasn't to be an issue because it's the default on Terraform to not be versioned, but the code didn't explicitly say it. So basically, we can, let me go to S3 and let me go to the bucket. Oh, I'm not sharing. Yeah, I'm sharing the AWS console. Sorry for that. So now we are on this MosQ3 bucket that we created using the Terraform that you saw. And basically, we're going to do manually what they did through script. And basically, we're just going to enable this. So now, good, this is enabled. And let me show my terminal. And what do you think? Terraform apply will report nothing. So this poor team versioned for weeks, hundreds and hundreds of terabytes a day of binaries until they received the bill, which is sad. That's a sad monitoring technique. So let me go back to the slide. So there is a lot of solutions in our ecosystem to work around the kind of things that we just saw, like policy and compliance tools like Sentinel, etc. That's a very different set of tools, very cool and very protective if that's what you need and want. All the testing and verification tools like TerraTest is written in Go. It's really great in spec. It's for like the older of us, like it's written in Ruby. It comes from the chef days. I really like inspect, in fact. Static analysis tools like Checkoff and more, they are there to help you analyze your code before you actually push them to your CI system, or if they are deployed on the CI/CD systems, they are there to prevent you to push things like allow anything to anyone directly on the code. And this implies that you have a CI/CD system. Today you have plenty of solutions, including things like Atlantis that do manage your pull requests, etc. for you very easily. It's all open source, obviously. So that's where drift control enters. We built to manage this drift, all those expectations that were not met for us. So we built this solution, open source solution for drift management, and because we wanted to be alerted, we wanted to have reports, and we wanted to know all the discrepancies between the state and the reality on the AWS accounts. So let me share my screen. Here we are. So we can start. We can start with by just using the same terminal, the same session that we had demonstrated. And right now, drift control will basically report you all the changes that you could not see with Terraform Plan, Terraform apply. So we can see the rules that allowed anything to anywhere on IPv6 and 4. So you know now that there is rules that were not expected. We have the policy attachment to MosQ3 that intern. So probably with your eyes of administrative guy, DevOps, whatever you are, it probably doesn't match. It should ring a bell that something is wrong here, actually. And there is a new access key even if you're not a security person, if you have a new access key creating out of nowhere reported to you, you should ring a bell. You should say, oh, that's not something I was expecting. So this is definitely not the job of Terraform. This is definitely the job of a tool like drift control. So those are unmanaged resources. Let me share this screen. Let's create, for example, a new bucket. Let's call it Fosdem 2031 to be in the future. And okay, so now it's created here, and we can go back to our terminal. And I would like, this is definitely not in Terraform because I just created live for you right now. So it's perfectly normal for Terraform not to report you that this specific bucket was created right now. But drift control, this is its specific job. I would like drift control to report me that an unmanaged resource was created. So now we have it live as well. So we have unmanaged resources, we have deltas from managed resources. If we go, I may have a couple of more seconds. So let me show you a VPC here. If we change something, security groups, if we change a rule, an existing rule here, and remove that, for example, allow anyone on this subnet, you can know about it in the diffs, in diff control. It's scanning. Let's go. All right, so no, it became an unmanaged resource because it's a new resource on AWS. All right. So this is the demo effect. So all right, the other things we can do with Terraform, with drift control, is ignore some resources that you do not want to see reported because they are there for testing or whatever reason they are here. But we can also filter using the same system than AWS CLI. It's using JMSPath. And basically, we can filter just for S3 buckets if the rest, you're not interested in the rest. So right now, we can just know about S3 buckets. So it's pretty cool for auditing purposes, for monitoring purposes, etc. So let me go back to the slides. Here we are. So drift control currently supports major resources on AWS. More are added every day. We will support absolutely any kind of providers in the end. The Terraform state is supported locally or on S3, but we're working on more as well, like Terraform Cloud, obviously. We have filtering and ignore support in place. It's written in Go. The license is Apache 2. And well, hopefully we'll see you on our community Discord server. We have channels for you, support and development. We live code there very often as well. We are available on Twitter and GitHub, and so I really hope to see you soon and use drift control so you can stop drifting and you can have all your evenings. So thank you for attending this talk and see you soon. Bye-bye.